For this example, assume no initial energy stored. Then find I of t at t greater than 0. We have at t greater than 0, so the switch is closed. We have, since we have a source connected to an RLC circuit, the response is composed of forced response or the steady state response plus the natural response or the transient response. Now solving for the forced response, so for IF, I have this circuit. IF and we have, assuming this is minus DC. So our IF just equivalent to, we have 20 over 10. This is negative equal to negative 2 amperes. Now going back to the circuit, we have for IC, and let's label this as plus minus VC, and we have plus minus VL. We have the current I1. So if this is current I1, this is also current I1. Our VL is equivalent to L dI1 dt. Capacitor current is equivalent to C dV C dt. For our voltage in terms of current, IC is just equivalent to 1 over C integral of IC dt plus initial value of C. Applying KVL at loop 1, we have negative 20 plus 6 I1 plus VC plus VL is equal to 0. So if we take a look at this branch right here, this branch, you can see that our VC is equivalent to negative 4I. So using this equation for VC, VC is equivalent to 1 over C integral of IC dt, and since there is no initial energy stored, so VO is just equivalent to 0. So this is equal to negative 4I. So deriving both sides, we have IC just equivalent to negative 4C dI over dt. Applying KCL at this node, let's label this as node A. We have IC is equivalent to I plus I1. So expressing I1 in terms of IC and I, so I1 is just equal to IC minus I. We have equation 1 and equation 2. Continuing with this equation, we have negative 20 plus 6 times I1 can be expressed as IC minus I in equation number 2, then plus VC can be expressed as negative 4I, and plus VL can be expressed as L dI1 dt equal to 0. So where I1 is thus equivalent to IC minus I using equation number 2. So this equation becomes negative 20 plus 6IC minus 6I minus 4I plus L di t dt minus L di dt equal to 0. Now remember our IC from equation number 1 is equal to negative 4C di dt. So this becomes dt equal to 0. Now rearranging this equation and dividing it by negative 4LC, so this becomes equal to negative 500. So we have this differential equation. Now to get the expression for the natural response, we need to get the characteristic equation. So the characteristic equation is s squared plus 30.25s plus 250 equal to 0. Our roots s1 and s2 is equal to negative 15.125 plus minus j 4.608 rad per second. So our circuit is an underdamped circuit. So our expression for IN is equal to our complete response. We have our forced response right here and our natural response. Now to get the coefficients for the natural response, coefficients A and B, we need the initial conditions. So for our initial conditions, we need I of 0 plus, then and then di dt of 0 plus. Now to get the I of 0 plus, look at this equation. Vc is just equal to negative 4I. Since we all know that the capacitor voltage does not change instantaneously, since there is no initial energy stored, our Vc of 0 plus is just equivalent to 0. So we have Vc of 0 plus equal to 0 is equal to negative 4 times I of 0 plus. So our I of 0 plus is equal to 0. We have value of 0. Now getting the value of di over dt, we can use equation number 1. Equation number 1, we have IC at 0 plus is equal to negative 4 t di dt at 0 plus. So how do we get the value of IC at 0 plus? So using equation number 2, we have I1 of 0 plus equal to IC of 0 plus minus I of 0 plus. Now IC of 0 plus just equal to I1 of 0 plus I of 0 plus. So I1 of 0 plus is 0 plus I of 0 plus is 0. So IC of 0 plus is just equal to 0. So if this is 0, our di dt of 0 plus is equal to 0. We have 0. We have now our two initial values. Writing the complete response, I have I of t is equal to, so at t equals to 0, or I of 0 just equal to 0. So our equation becomes 0 equals to negative 2 plus a plus 0. So a just equal to 2. For di dt at 0 is just equal to, so we have negative alpha a plus wd b. So solving for the value of b, or b is just equal to 6.565. So our complete response, I of t equal to negative 2 plus e to the negative 15.125t times 2 cosine of 4.608t plus 6.565 sine of 4.608t times u of t amperes. We have our heat response.